Dear students and the participants on the course on railway engineering, today we are going to discuss few of the things which are left in the case of permanent way renewals, and then we will shift to the another aspect, that is drainage on tracks. If you remember, in the previous lecture we talked about the various types of maintenance practices which are to be taken up in the case of circuited or non-circuited tracks. We discussed about the measured shovel packing. We talked about the various precautions which needs to be taken up in the case of circuited areas or the electrified areas of the track. And then we started discussing the permanent way renewals, and towards the end of that lecture we were talking about the through sleeper renewals. In this lecture we are going to take up the renewal of the points and crossings, and then we will look at some of the features of the track renewal train, which in short is also being known as TRT. After that we will start our discussion on drainage, wherein we will be discussing about the various requirements. The requirements are in terms of the drainage and the effects which may happen on a track, and then we will be taking up the drainage at different locations between the stations, at the station yards or at the platforms. And finally, we will touch upon the subsurface drainage practices. Now, starting with our permanent way renewals. Now, this permanent way renewal at points and switches. So, when this is to be taken up, that is criteria we are going to talk here. So, if the wear on the switches and the crossings, it reaches the limits. We already discussed about the maintenance practices, and therein we talked about the planned maintenance, we talked about the need based maintenance or urgent maintenance, and all of those things, they were related with the permissible limits of the various types of distresses which can occur in a track. Considering that, here again we are talking about the similar practices to be adopted in terms of the various distresses and their permissible limits. So, we are discussing here the chipped length. Now, this chipped length, it aggregates 200 mm within a distance of 1000 mm from its toe, and one chip, when we are talking, this one chip is considered as 10 mm over a continuous length of 10 mm. So, if this is a condition which is happening at any of the switch, then that means there is a requirement for going for a renewal. Or if it is badly twisted or bent and does not house properly against the stock rail. So, when you are talking about the stock rail is straight like this, and then there was a heel block, and with respect to this heel block, then another rail was provided which was a tongue rail. So, this is a tongue rail and this one is a stock rail. Now, what we are talking is that when this tongue rail comes and touches the stock rail, how it is getting fit in here. So, it says that if it is badly twisted or it is bent or it does not house properly against the stock rail, causing a gap of 5 mm or more at the toe. So, this is the heel and on this side is the toe. So, here if this gap comes out to be equals to or greater than 5 mm, then again we have to go for a renewal. Or the vertical wear on the wing rails or the nose of the crossing, it exceeds 10 mm, then also we have to go for the renewal. But when we are talking about this 10 mm, we have to consider the effect of the slope, which is 1 in 20. So, therefore, whatever is the value which is going to be there because of the slope has to be detected from the vertical wear value which is measured, and then after that if it exceeds 10 mm, then that has to be considered. Then another thing is when it crosses the minimum total traffic in GMT. Previously also we have discussed about the traffic density in the gross million tons. We discussed about even the fastenings or fittings also, different types of fastenings were there. So, here three types of switches which we have: the fabricated switches, the thick web switches or the CMS crossing, and all of these again we discussed when we have discussed about the points and switches. Now, in these three cases again we can have two types of the rail sections. One rail section can be 52 kg per meter, another rail section can be 60 kg per meter. So, in the case of the fabricated switch, if the rail section is 52 kg per meter, then this traffic density is taken as 150 GMT. So, as soon as it crosses 150 GMT, that means there is a requirement of a renewal. But if it is 60 kg per meter rail section, then this value increases to 200 GMT. When we have a thick web switch, a better switch in this case. So, even for this 52 kg per meter rail section, you can see the increase from 150 to 500 GMT. And similarly, in the case of 60 kg per meter, here also it is from 200 to 500 GMT. So, a good increase in the value is there. That means, now in this case the requirement of the renewal is going to be at a much longer span rather than in the previous case. The third case is the CMS crossing, the cast manganese steel crossing, and in this case if you are considering 52 kg per meter rail section, then the value increases to 300 GMT. That means, now it is falling in between the two cases, the fabricated and the thick web switch. These two cases are there. So, this is falling somewhere in between that. And similarly, for 60 kg per meter also it is 300 GMT. So, these are the limits which are specified, and as soon as the traffic is becoming more than this, or the trains, the number of trains which have travelled on that particular section having these type of switches, it goes beyond these values, then we should go for a renewal. The another one is when the through sleeper renewal, the TSR, is due. So, in that case also we can also look at the points and switches again. When the rail section on either side is changed to a higher section in the through running lines, at that point, because when you are changing the rail sections, now the other things can also be changed, so that the requirement of the maintenance comes at the same time, not at the different times, and again you have to go for those type of component renewals. Then there are some points which needs to be taken into consideration. So, here the points are related with the station yards. Renewal should bring improvement in the layout. Whenever we are going for a renewal, it should not be that whatever was there, just some replacement has been done there. That should not be the basis. The basis should be that how we can improve upon the things there, how we can make the system more efficient, how we can reduce the delays, how we can reduce the requirement of maintenances over a period of time. So, all of those things are important when we go for those renewals. Standard rail sections shall be used, and these standard rail sections, they are already being notified by on the Indian Railways by RDSO, and when we discussed about the various rail sections, at that time we have looked at different type of sections. At least one rail length on either side of the turnout should have the same section of rail as the turnout. So, if we are talking about a turnout and say it comes out in this form. So, what it says is on either side of the turnout. So, the turnout say ends here, it starts from here. So, on either side means on this side as well as on this side. So, this rail section should be the same as that of the turnout. So, for a certain length it has to be same. The intersection point of the turnout track and the main line track shall be fixed accurately, as these are used as references for the measurement of other points. So, the point of intersection of the turnout track and the main track. So, this is the point of intersection here. So, we are talking about this crossing which has got created. So, it has to be done accurately, because with respect to this, then the rest of the values are going to be considered. If you remember, when we have designed the turnouts, we did talk about that from the distances are being taken from T and C, the theoretical nose of the crossing. With respect to that, we were going this direction, and there the different type of leads were defined, and we have calculated those leads. Similarly, in some of the cases when we said that there is this curvature is stopping at a distance x from the TNC, then again the TNC comes into picture. So, that is the reason that you need to look at this particular aspect of accurately finding out the position of the intersection point. The joints on the SRG and lead rail should be welded. Then the new gauge tie plates shall be used. So, when you are going for an upgradation, when you are going for a renewal, the new items are going to be taken into consideration. That means it becomes a primary renewal. Before connecting the stretcher bars, each tongue rail should be checked regarding the fitting properly against the stock rail up to JOH, that is the junction of the rail head, without applying any pressure to it to bring it to the position. So, as I have shown in the previous diagram, so if we go back, so this diagram we are talking about. So, here this tongue rail, when it is touching and getting fit at this particular point, it should not happen that we have to put some pressure, and by putting that pressure we can show yes, the tongue rail is fitting well with the stock rail. So, that should not be done. That is what it is speaking here, that before connecting the stretcher bars, each tongue rail should be checked regarding fitting properly against the stock rail, but we should not apply any pressure here. And once it is being checked, when it is being observed that it is fitting well with the stock rail, then those stretcher bars can be put in, so that both of the tongue rails they move equally in either of the direction. Now, the procedure which is there, the procedure we have discussed previously. So, in short we are talking about that procedure. It says the deep screening of the ballast, place it up to the bottom of the sleeper. So, shallow screening is also to be looked at, and deep screening is also to be looked at. But when you are going already for a deep screening, it means if you take the sleeper, so there is some aggregates which are here on the side, as well as there are aggregates at the bottom, and they are going up to the formation level. Okay, so that is what we are talking. So, when you are going to the deep screening, it means we are going up to the formation level, and we have to place it at the bottom of the sleepers. So, that means we are just packing it here and then boxing the other side. So, packing and boxing is also we are talking. Extra ballast is being kept for the boxing. Then keep rail cutting and rail drilling machines ready. So, if there is any section of the rail which has gone bad, so in that case that has to be cut and a new rail section has to be placed. That we discussed when we were talking about the various types of fractures or the failures of the rail sections. So, the rail cutting machines or the rail drilling machines, they should be available at that location where the renewal is going on. So, as per the requirement they can be used. Turnout can be assembled at site manually. That means whatever is the turnout which is provided, we are simply just removing the items from here, say whatever these lengths are there, or we are providing the jack rails, wing rails, etc. So, everything which are being provided, we are just taking out those things. So, this is on site renewal. The another can be that assembling manually by the side of the existing layout. That means this is already there. What we do is we start assembling it here. Okay. So, there is a stock rail, then we have put the this turnout rail like this. So, this is being assembled here, and then finally it is going to be placed on this side. That means that much portion will be taken out and we will place it there. So, the assembling on the side, but when we are doing this assembling on the side, that means you require a clear ground for that. clear and the leveled ground. So, if that is available, adequate space is available, then only this is possible that we make one just a replica of the turnout and then use it. Or it can be pre-assembled and lay by using the machines. That means at some other location that is being pre-assembled and then the machines are there, they just lift it, they brought on the location and then that is being placed on the track. So, this is another way and this can be a faster way of doing it. It is not interrupting anything, because if you are working on the site when you are taking out suppose this rail, now it means this cannot be used for the movement of the trains towards the turnout, as well as the restriction of the speeds also needs to be done. Similarly, when even you have made it on the side of the track and now you are putting it there, still some block time has to be taken, so that this can be done. But then in that case again there will be disruption of the traffic. Now, let us talk about something for the TRT, that is the track renewal or relaying train. On the side there is a photograph, you can see there is a one big assembly. This big assembly is actually the track renewal train or relaying train. So, it has all the facilities which are required when you go for construction of a track or when you go for a renewal of a track. So, it has a main vehicle which has sleeper handling device. That means the number of sleepers which are there, they will be put on this train, and then there is a device which will take those sleepers from there and it will be put in the particular location where they have to be placed in a square. So, another thing is that whatever sleepers in the case of a renewal, they are coming out. So, it can also take out those renewals sleepers, will put it at the site and the new sleepers will be placed in place of those, and then finally the old sleepers will again be taken back. So, it removes the old sleepers also as well as place the new sleepers. Then there is another system which is rail lifting and guidance system. Now, this rail lifting and guidance system means the rail on which say it is moving, that this rail can be lifted, the sleepers can be either taken out or can be placed, and then again the rails can be put back on this. Now, this lifting they can be up to 50 mm, which is the usual limit up to which we work, but it can be more than that also as per the requirement and as per the permissions which have been taken from the authorities. A triangular smoothing plug and compacting plate is also there, which helps in preparing the ballast. Now, the handling gantry which is provided, so handling gantry will be here at this point. So, it can lift 20 sleepers at a time. So, that means it will pick up 20 sleepers and will brought to the location on this track itself, and then will start laying those sleepers one by one based on what is the specified spacing at which they needs to be laid, and it can travel at a maximum speed of 15 kilometers per hour. So, here you can see that in this photograph that the number of sleepers as well as the rail they have been lifted up. So, these are the already used sleepers. Now, if they have to be taken out, then there is another procedure of doing it. There is a set of BFRs, this is bogie flat for rails, which are used to handle sleepers. It can work with a speed of 720 meters per an hour. Then how this TRT works? First of all, what needs to be done is you have to remove the fastenings. If you have to take out everything, say you are changing the rails, you are changing the sleepers, then obviously the fastenings have to be taken out. So, these fastenings will be taken from the combination of the old rails and sleepers. Then the placement of the new rails, they are usually put at 1.5 meter from the track. So, on the side of the track the rails are already being placed. Then positioning on the track, that means this whole of the assembly, the whole of the train will come on the alignment. So, whatever is the alignment is there, this train will come on that. So, there is a provision, there is a system which is being provided with the help of which it will come there. So, there are the guidance sleds, those guidance sleds with the help of that it will come on the track. Then it will lift the old rails, screens the ballast, and For that, it will be using the rail lifting and guidance system as well as the BCM, that is the ballast cleaning machine. So, it means now it also has another machine which is ballast cleaning machine. So, it has a system for sleepers, it has system for rails, it has system for ballast, everything is there. Then it picks up of old sleepers and they are placed on the conveyor system and they will go back into the train. So, it means now you are stacking the old sleepers at one location, the new sleepers will come again and this recycling will keep going as per the movement along the track. Then leveling and compaction of the ballast bed, this is being done using the vibratory blow and compactor. Then laying of the new sleepers, laying of the new rails, then fixing the insulators and the elastic fastenings, and then finally picking up of the old rails which have been placed on the side. So, all of these things this machine is capable to do. That means a lot of work for which a lot of manpower is required and it will take lot of time to do that is being executed by this machine and it is done in a much faster manner. Now, let us talk about the track drainage. Now, why the track drainage is required? To avoid the settlements of the embankment or to avoid the possibility of the variation in the cross levels of the rails. So, we have the section. So, a ballast cushion is there, the formation level is there, this is ballast cushion, and then at the top of the ballast cushion the sleepers are provided, and then at the top of the sleepers the rails are provided. Now, suppose the water comes here. Now, this water will start moving in these two areas, and when it starts moving in these two areas it will cause a problem in terms of their strength properties. And if this gets reflected towards the top and if the loads are coming on these rails, then there is a possibility that any of the side of this rail or a whole of the track may come down. And if it comes down and if there is a difference in the level by which it comes down, then that means there is a problem with respect to the cross levels. And now, if the train moves at the top of it, there is always a possibility of a derailment. To ensure the stability of the formation and the track in terms of the bearing capacity and the resistance to shear. So, that is what we are talking here, that this is stability as the water seeps in. So, whatever is the density with which they have been compacted, then this density will reduce because of the presence of the water, and therefore, its load taking capacity will reduce. To avoid the failure of an embankment due to loss of the bearing capacity as well as due to the self weight, because this whole material this is having a self weight. Along with that, if the train is coming at the top, this also is having certain weight. So, all of these weights, if they are coming down and the water has already seeped in, then in that case there is a possibility that this embankment may fail, and if embankment fails means there is a possibility that this material can flow like this. So, if this material flows in this form, then the stability of the system is gone and it will not be able to take up the loads. To avoid the formation of the ballast pockets. Now, sometimes what happens is the ballast is getting choked over the time period, and if this water comes, then there is a possibility that water remains here in this area or remains here in this area. Now, if it remains there, then again it will start deteriorating the material which has been used here as a ballast, and that will have the further effects in terms of loosening, in terms of the problems with respect to the drainage which will be there. So, all of those things needs to be taken care of. Now, here another thing which happens is the bouncing and pitching effects. This bouncing and pitching effects again we did talk about these in terms of an x axis, in terms of an y axis, in terms of an z axis, the movements along those axes and the rotational movements about those axes we have already discussed in one of the lectures. Now, another thing is to ensure the banks do not shrink or they do not crack. Now, it also depends upon the type of the soil which is there. Say it's a black cotton soil. So, in the case of a black cotton soil, there is a possibility that if it dries, then it becomes harder, but as soon as the water seeps into that, then it loses its strength. Similarly, based on this drying and the wet cycles which will be there, the shrinkage cracks will appear in the surface. So, you will find that if there is an area with the soil, some sort of cracks will be observed in this form. Different type of orientations can be there. To reduce the negative effects if the formation is black cotton soil, we just talked about it, the expansion and the shrinkage cracks can be there. To avoid the formation of slush, which is causing the clogging of the ballast under the dynamic loads. Now, what are the various sources? The various sources are the gravity water, and the gravity water is the one which is there at the top of the surface. It may be there in the form of a precipitation or the flooding from any of the areas, and then as soon as this water comes at the top of the surface, and then it starts moving into the subgrade under the gravity. So, again if we are going with the same diagram, so there is possibility that the water has accumulated here, but we said that this is a formation level and this is the ballast cushion. Now, this water is seeping inside. Now, you have to control this, otherwise as we have discussed, it is going to create a problem in terms of the strength, in terms of the shear properties, in terms of the load taking capacity, in terms of the various types of distresses which are going to be introduced here, say shrinkage and cracks, etc., or the settlement. So, how we can control them? Provision of the surface drainage. That means if there are drains which are already being provided, and say these are the lined drains, then that means all of this water comes into these drains and then it will be taken to a outfall. So, wherever the outfall is there, this water will go and it will get into the nala or in the river, whatever type of outfall is provided. Then the lowering of the cess. So, we need to look in this area. Then turfing of the side slopes of the embankments, that means now we are providing some protection on the side so that the embankment does not fail. So, there are different type of techniques, there can be stone pitching, there can be use of geotextiles with the help of which we can protect the sides of this embankment. Now, another way of coming of the water is a capillary action. Now, what's capillary action is, say there is this level where the groundwater table is. Now, if this comes very nearer to the subgrade level here, then there is a possibility that this water will start moving in the up direction. And if this water starts moving in the up direction, then slowly the properties of the material here are going to be facing problems. It will get reduced in terms of the required values. So, this capillary action is going to be dependent on one, the presence of water, and another thing in this area, the type of soil, because not each and every type of soil is going to support the movement of water by capillary action. So, the type of soil is one aspect and the presence of water is another thing. If both of these things are there, then this can happen. So, this is the water which moves up from the groundwater table or seepage water under the action of capillary effect. It can be controlled by providing a pervious layer which acts as a capillary break. So, what we can do is, now in this case we can provide a pervious layer here, and this pervious layer is provided with a slope. So, there is a 1 in n slope here and 1 in n slope here with respect to the center line. So, now whatever water comes, now this is a granular material. So, this water if it comes will flow outside from here and it will not go further up. So, this is an additional layer which needs to be provided, and this thickness of the layer is extra than the thickness of the ballast cushion. Then another way is the from adjacent areas. So, water seeping from sources in the vicinity into the subgrade. So, It may happen that though there is no problem in this area where the track is being provided, but at some distance away, say there is a nala and the water comes in this nala, and because it is not a lined one and it is a continuous flow of water which is going into this nala or a river. So, there is a possibility that this water will start seeping towards the embankment, towards this track. So, this is the type of issue which can be there when we are looking at this from adjacent areas. Now, diverting the water from the source away from the embankment, if it is possible, then that is the best thing, that if we can do something here and we divert the water back, then that will be helpful, or providing effective paved catch water drains. So, the another way is that we are providing the catch water drains which are lined. So, at some depth, if we are doing based on the way the water is flowing, if it is flowing from the top surface, then this will get into the catch water drain, and then it is further taken through the sloped system outside, providing inverted filters and the underground drains. That is another way of doing it. Then hygroscopic action from the atmosphere is also possible, but because the amount of moisture which is available in the atmosphere is not so high, therefore, this is not going to make a big impact to the subgrade moisture. So, this is in general not a case of concern. Now, what are the requirements for the good track drainage? The surface water should not stand in the track. The side drains should have effective size and slope to carry the water. The longitudinal drains which are provided between the two tracks should have a saucer shape. Saucer shape means a curved shape, so that the water from this side and the water from this side can get into it. Then design of drain shall be such that it allows the periodic inspection and cleaning. That means it should be open from the top, and the whatever design which has been provided, it should be easier to clean periodically, so that the material does not fill in that location and chokes. Then top of the drain shall be below the cess level to ensure effective drainage of the ballast bed. The sides and slopes of the banks shall not get eroded. So, for that we discussed that what can be the way we can protect the embankment slope. Then soil in the formation and the subgrade, it should be such that it is more permeable and do not help in the capillary rise of the water. So, that is where I said the type of soil matters. So, if it is a silty soil, then there is a more possibility of having this type of a movement of water. So, we need to look at that. Proper subsurface drainage measures shall be taken. We will be talking about these just towards the end. Then longitudinal drains shall have a proper outfall. So, that means first of all you have to design it, that what should be the depth, that means this depth, what should be the width, and then what is the slope. All of these things needs to be designed, and along with that what is the velocity with which the water is going to flow in it. So, once that is being done, then on the basis of the outfall where it is available, it will go up to that and will drain into it. A special arrangement shall be made for waterlogged areas as well as for the various perennial problems, but then they are specific to a problem. Accordingly, the solutions needs to be identified. Now, here the drainages in the mid section between stations, side drains. You can see here a side drain being provided at the side of the track. They should be provided along the track in cutting and zero fill locations where the cess level is not above the ground level. These are provided with an adequate slope so that the collected water can flow freely. Just I was talking in the previous slide about this. Then adequate opening shall be provided under the level crossings or the locations where the trolley refuges are there, or around the OHE, the overhead electrification systems, so that the water do not accumulate at that location and create a problem. In general, they should be provided with a lining. So, as you can see here that the lining is provided. So, concrete structure is being created in terms of a U shape here. Now, based on the terrain conditions, the catch water drains of adequate size should be provided. So, if it is an undulating terrain and here the track is provided, and so the water which is coming to flow from here, it is better that if we can catch them at this location. So, that is a catch water drain. So, this water now will not flow to the bottom, and from here it will be taken to an outfall. Surplus ballast in the shoulders of the track, it retards drainage, as well as there is a possibility that the vegetation can grow in that area. So, it is better to take out that extra ballast, and the stacking shall be in the small heaps beside the tracks. Then in the case of the station yards, we can have the open surface drains as we just talked. They can be open from the top to allow inspection as well as cleaning. In case of the earthen drains, the velocity shall be in the range of 0.5 meter per second to 1 meter per second. So, the flow velocity is this value which is taken for a design, whereas if it is a lined one, then it can be more, it is 1 to 2 meter per second. I already said that the saucer shaped drains should be preferred, but it is not that it is a guideline and it has to be taken. Mandatory system is not there. If there is a requirement, we can go for other designs also. So, these are the longitudinal drains which are provided between the two tracks, and they have the curved sides, so that the water from both the sides can get accumulated in it. Drains with vertical sides can also be used if there is a such condition. Then normally the drain top should not be above the cess level, and the effective drainage in the ballast has to be ensured. In case the above is not feasible, then what we do is we provide the weep holes at the assumed level of the cess, so that the water through that will come through these weep holes into the drain. The slope shall be aligned based on the location of the outfall. If it is available at both the ends, then the slope of the drain shall move away towards the ends from the center of the yard. So, that means there is an outfall here and there is an outfall at this point. So, this is one outfall, this is another outfall, and the yard is in between. So, the drains which we are providing, so it should happen in this form, that from the center area it should slope to both of the directions. So, that from half of the area the water comes on this side, and from half of the area water comes to the other side. A network of longitudinal and cross drains shall be provided to carry away the water. So, wherever there are problems, it is not that we are providing only the longitudinal drains here. There is a requirement, then we can go for these type of cross drains, and they are connected with each other, so that the water when it comes in one can be taken through other towards the outside. Then arrangement for the drainage of water and water columns and carriage water points with washing hydrant should be efficient and maintained. So, wherever such washing systems are being provided, we need to be more cautious there. In the case of station platforms, platforms shall slope away from the track. So, that if the track is at this level and this is a platform provided, so it should have a slope in this way. All drains from the platform side should be enclosed in pipes, and the pipe should discharge the content towards the non-track side. So, if there is a track here, so whatever the pipes are provided, those pipes will be draining outside on this particular area. But there is a possibility that you have a platform and there is a track on this side as well as a track on this side. So, this is defined as an island platform. So, in this case, to which direction you have to take that content, and the discharge has to be done. So, it says that it should be done in towards that particular area which is not of that important as compared to other side. So, if it is a main through line on this side and it is a loop line on the other side, then this has to be taken towards the loop line. Covered longitudinal drain should be provided if required. This as I already talked. So, if the case of island platform where the discharge of the content should go towards the less important side. Then subsurface drainages, there can be an inverted filter. This can be provided as a blanket of non-cohesive graded material. We have shown you in one of the diagram which I made that at the top of the formation level, one complete layer towards the entire width of the formation is provided of certain thicknesses. So, the thickness of the layer can be 300 mm on a clay soil. It can be increased also depending on what type of properties are there. This may contain plastic fines not exceeding 5% or the non-plastic fines not exceeding 12%. In this macadam form, the liquid limit shall not exceed 35 and plasticity index shall be below 10. So, this liquid limit and plasticity index you must be knowing if you have read the soil mechanics. So, this LL is liquid limit and PI is plastic index, and this is a difference of LL minus PL, where PL is the plastic limit. The uniformity coefficient shall be above 4, desirably above 7. The uniformity coefficient is written as Cu, and the coefficient of curvature, that is Cc, it should be between 1 and 3. So, there is a formula so as to calculate this value. Now, in the case of poorly graded gravel or poorly graded sand, the Cu should be greater than 2 for and as well as for Cu greater than 2. Then for this silty gravel and the clay gravel mix, in all of these cases the depth is 450 mm. We started with 300 mm, now we are increasing it depending on the type of material. Say if it is a clay gravel or it is a silty sand or it is a clayey sand or it is a silty clay sand, then in that case it is 600 mm. So, G is for gravel, M is for silt, C is for clay, then P is for poor, so poorly graded. Okay, so and that is S is for sand. So, on the basis of that, now you can make the combination. So, this is ML. Now, here we are talking about L. So, this is low plastic, I is for medium plastic. In this case, it goes to 1000 mm. There is another way we can use the sand piles. That means the sand piles are driven inside in this form into the formation. So, these can be of a diameter 200 mm. The total cross sectional area of the sand piles is kept as 20% of the formation area. So, if we are talking about this area, so in how much area those sand piles are being provided. So, that has to be identified on the basis of this total area. So, total area, this is 20% of the total area. The depth is 2 to 3 meters. The water rises through the sand piles to the surface through the capillary action and can evaporate at the top surface. There is another way of doing is cement grouting, but it is a very costly affair because you are using cement. So, it is used at locations where there are the formation of water pockets, but if these water pockets are small in size, then of course, we can use this type of a method. The slurry of the cement and sand is pumped into the embankment by using the pneumatic injection. The ratio of cement and sand is 1:2 to 1:6, and the pressure at which it is injected is 4.2 kg per centimeter square. Then pumping is continued till the grout appears through the ballast and reaches its top surface. It helps in filling the cracks, thus preventing the water to flow into the subgrade. And as I said, this is a costly affair because of the material being used. Another way is we can have the paved catch water drains, which we already discussed. At different locations it can be provided so as to entrap the water and take it away from the location. Another problem can be a water pockets in the ballast. Now, these water pockets, when they are being formed, we discussed in the case of a deep screening also, then we can go for the deep screening and the pervious layer can be provided where this type of a problem is occurring again and again, so that the water drains through that. As I said previously too, if there is a small area where the water pocket is creating, that cement grouting can be done. In case the water gets trapped in a ballast due to an impervious layer which is falling on a pervious layer. So, there is a layer at the top here and then there is a layer at the bottom. So, this is impervious and this one is pervious. So, when this is impervious, that means the water cannot seep through it. It will simply either drain to the sides or it will get accumulated here only. But there is a pervious layer at the bottom. Of this impervious layer is thin, then what we can do is we can put the holes in this. So, the holes are drilled, and through that holes the water will go to the pervious layer, and then finally it will go to the lower substrata. Perforated pipes is another option. You just insert the perforated pipes. These have the holes all along the length. So, whatever water comes into it will be get drained, but then we have to use the type of material so that it does not get choked. Counterfeit drains, that can be another way of doing. It can be usually 600 mm wide and is spaced at an interval of around 10 meters. So, with this we close our discussion on the drainage. So, what we started discussing was the renewal of the points and crossings, and then we moved to the drainage requirements, then why it is required, what are the problems which are being faced, how it can be done in the station areas, between the tracks or the platforms, and then some more information was taken up with respect to the subsurface drainage systems. We are stopping here. We will be meeting in the next lecture. Till then, thank you and bye.